Well, dear friends, I told you refraction formula for a spherical surface, that is n upon v minus 1 upon u equal to n minus 1 upon r. Refraction formula for spherical reflecting surface, whether convex or concave. Actually, during learning sometime, I should say generally, the basic facts are lost. We don't know why we are studying this thing, why we are actually involved in studying so many things. So we have to take care of that also. We are studying, we are learning, we are teaching you just to know the basic facts which are happening around us. This refraction, is helping us throughout our life, starting from morning to late night, evening. Here the aim of refraction is to learn about the effect of light, and where we use lenses in our goggles, we use telescope, we use microscope, and these are basic facts about that. How so precise instruments have been designed, and due to actually syllabus problem, many facts have been removed from the book. What is that here, please? So, spherical surface. But it was convex surface, and here, if we place the object somewhere, so rays were going diverging, there be converging. Real image milta hai, we get real image, or it was convex, concave surface. It diverges the beam like this, and images go obtained like this. So, to understand this converging, diverging behavior, here a fundamental thing is required, which is called focus. So I will telling you principle foci. Principle foci. Some people like double I also. People focus is foci of spherical refracting surface. Refracting surfaces. If we don't understand what the meaning of focus, then it is useless to study. And no book is there in which this definition has been given. Initially, I found this definition in some books, but now, to reduce the volume of syllabus, we are misguiding the students and people. I am sorry to say this thing. So there are two foci. Number one, first focus. First focus. What is that? Here, suppose it is convex refracting surface, and there is a point on principal axis from which a diverging beam after refraction become parallel to this. This is first focus. Like in our body, in Hindi we call it nadhi. Our body is connected to the spine through small veins, and I don't know the term used in biology. In case concave surface, it is concave surface. What is there? A beam was just to converge at this point. If the rays become parallel, then the first focus of concave surface. Focus. The aim of this learning this topic, refraction of surface, is to understand how the light rays converge or diverge. So how to define first focus? How to define first focus? There is a point on principal axis of spherical refracting surface from which a diverging beam, convex surface, or a beam converging to it, concave surface. Becomes parallel to principal axis. Principal axis after refraction. This point is called first focus. This point on principal axis is called first focus. First focus. For, I am telling again, in case of convex surface, this point F1 from which diverging beam after it become parallel, first focus, or beam converging to a point on principal axis in case of concave surface, become parallel to principal axis after refraction. This point is called first focus of the spherical surface. For convex surface, this point for convex surface, first focus is a real point, and for concave it is virtual point. I hope you have got my point. Without understanding this, we will not be able to understand further topics, convex, concave lens. So, ultimately, if object placed at first focus the image will be at infinity. In this case, if virtual object, this point F1 is virtual point, so if there is virtual object on first focus, the image at infinity. In general, we are taking the first and second focus, first focus of convex or concave surfaces will be different from different colors, because I told you different x n varies from one color to another. It is maximum for violet and least for red. But in general, by taking average different x n, by definition, of first focus, if object is at first focus, then image is at infinity. So using u equal to f1 and v equal to infinity in refraction formula, we get what is the formula? N upon v minus is equal to n minus 1 upon r. We get n upon infinity minus 1 upon f1 equal to n minus 1 upon r. Or you can write it is 0, 1 upon f1 equal to minus n minus 1 upon r. Or f1 is equal to minus r upon n minus 1. So here this this is called focal length actually. F1 here focal length, distance of focus from pole is called focal length, F1. For convex surface, R positive, so F1 negative. For concave surface, R negative, so negative into positive, so it lies inside. So this is something about first focus. Now I come to second focus. Please try to understand focus. You daily use this word focus. And teacher always say you, parents always say you that focus on your studies means concentrate on your studies. Focus means we are making something concentrate at one point. So we are studying here because these refracting surfaces are making either concentrate or they are diverging light coming from a point. Both facts are there. These surfaces converge as well as diverge also. Now second focus. Second focus. This is very important to know actually because of lack of time as well as lack of knowledge also. We keep on telling things other way. I request all of you whosoever is studying my or watching my video, please share and tell your friends and ask them to subscribe. Dear, you are children for me. After a hard labor, I could understand all these things myself from the books The authors initially actually they were using their wisdom for the benefit of society. Now second focus, in case of convex surface, again I take first convex surface. A parallel beam of light, I told you, beams of light converging, diverging parallel, really converge at a point. So this point is second focus for this. For concave surface, a parallel beam of light appear diverge from a point. ये dotted लाइन मैंने पहले बनाई, वैसे तो ये ग्राह यूं पीछे बढ़ा मिलता है, लेकिन ताकि एक पॉइंट से मिलते दिखाई दे तो हमने ये पहले से बनाया. So this is second focus. So remember here कि I have got f1 focal length minus r upon n minus 1. इसको याद रखें. Question in competitive exam, question are asked on these topics also. You can't pretend that this is not in syllabus. In syllabus, refraction is there, large refraction are there, and they are followed here. So this is supposed to be an application of large refraction, etc. We keep on pretending that it is not in syllabus, so leave it. So how to define it? Second focus. I should say like this: the ray parallel to principal axis of spherical refracting surfaces after refraction really converge to a point convex surface or appear to diverge. You understand the meaning of diverge? फैल जाना. Appear diverge from it convex surface, concave surface. Appear to ना क्या बोला मैं? The rays parallel to principal axis of spherical refracting surfaces after refraction really converge to a point or appear to diverge from it on principal axis. Really converge to a point this point on principal axis, this point on principal axis is called first focus. Second focus. And distance of second focus is called focal length f2. Point F, we mark capital F, means we are pointing for point, focus point. and small f focal length, distance from pole. So now, by definition again of focus, second focus. For convex surface it is real point, again it is virtual point. From definition, of second focus. If object is at infinity, then image is at second focus. So using v equal to infinity, sorry, u equal to infinity and v equal to f2, distance of second focus from pole, in refraction formula. क्या है फॉर्मूला? n upon v minus 1 upon u. Keep on writing again and again, you will be learning. Using this nano we get, what do we get? N upon infinity, n upon v, n upon, f2 minus 1 upon infinity equal to n minus 1 upon r, or n upon f2 equal to n minus 1 upon r, or f2 equal to nr, n minus 1. So distance of these focuses are different. First and second focus are at different distance. So if you see first focus, I have written there f1 is equal to r upon n minus 1 minus from, if we compare this or if I what to do from this f2 upon n is equal to r upon n minus 1. From here r upon n minus 1 is minus f1. So comparing this we get f2 upon n minus is equal to minus n minus f1, sorry. भाई ये कंपेयर किया हमने तो we get this thing, and from here we get f2 equal to minus n f1, यानी कि second focus is n times the first focus, focal length. Focal length of second focus is n times the focal length of first focus. They are not equidistant, please. है ना? और f2 plus n f1 is equal to 0. This question has been asked in competitive exam, and there actually n is different. So they started for a monochromatic light, means light of one color. f1, f2 are the focal length of first and second focus. Then prove this thing. I hope you will enjoy this. Please learn these basic things, though the video has become longer, but topic was so interesting that I could not limit the time of video. Please like this video, share them, read this carefully, watch this carefully, and learn the thing. This is a very basic fact which has been deleted from every book. Thank you.